let's talk about elastic potential energy that applies to springs, which will help you solve word problems such as this one. If you like learning with me, subscribe and comment the topic you want to study next. Let's start. If you have a spring at an equilibrium position and you apply a force, it stretches the spring. Let's assume that the stretch is x meters. Now, to stretch the spring, you did some work on it. And that work, which was in joules, that work was converted to potential energy in the spring. Now, when you let go, the spring will bounce back to its equilibrium position because it had that stored potential energy. The formula of potential energy of the spring is half kx square. From the last video, you might remember the formula of force of the spring, it's kx. The summary of the theory is that you do a work on the spring and that work gets converted into potential energy on that spring. So let's say that you did a work worth 100 joules on the spring. That will provide 100 joules of potential energy on the spring. So the formula potential energy is 100 should be equal to half times k times x square, where k is the spring constant in newtons per meter and x is the stretch of the spring in meters. Let's look at this problem. The spring is stretched by 0.3 meters. Look at the unit, meters. It means it's talking about length. And the length of stretch is given by x. So x is 0.3 meters. We also know the spring constant. So that is k, 60 newtons per meter. We need the potential energy of the spring. Using the formula half kx square, you plug in the numbers, half times 60 times 0.3 square. When you do the math, you get 2.7 joules. That is the potential energy of the spring. Let's see another one. You have a ball that's pushed into a spring. So we have a spring and you have a ball that's being pushed into it. Now when you do that, you are doing some work on the spring. Because of that, there will be some potential energy. And this ball is compressing the spring by 0.02 meters. So x is 0.02 meters. And we know the force is 40 newtons. So F is 40 newtons. We are trying to find the work done on the spring. We know the formula of work, it's the potential energy, which is half kx square. We know x, it's 0.02, but we don't know k. So let's find k first. We have F and we have x. We know the relation F is k times x. So when we plug in the numbers, 40 is equal to k times 0.02. From here, you can divide both sides by 0.02 and you get k as 2000 newtons per meter. Now that you have k, I will plug it in here. So the work would be half times 2000 times 0.02 whole square, which comes to 0.4 joules. That's the work done on the spring. If you understand these examples, try this word problem by yourself. You know the formulas, you know how to apply them. Write your answers in the comment below.